Engineers have a vital role in monitoring the quality of the contractor's work during a classroom construction project. This video has been prepared to guide engineers on how to effectively monitor the quality of construction at key points during the construction process. The four key stages of the construction process are: Stage 1. Pre-construction activities and documentation. Stage 2. Structural construction. Stage 3. Internal and external fittings. Stage 4. Finalization and handover. This video highlights the key tasks that the engineer should undertake during each of the four stages in order to ensure the classroom will be constructed to the quality standards demanded by DepEd. In addition, it also highlights the 6 key inspection points in the construction process when the engineer should make visits to the construction site in order to undertake quality assurance inspections as the work is progressing. In addition to watching this video, it is also important that the engineer should refer to the Engineering Standards Handbook, better known as the Blue Book, for detailed technical guidance on the task involved. Also, the engineer should get a copy of Simplified Construction Handbook for School Buildings, which is better known as the JICA Construction Handbook. The JICA summarizes the detailed technical guidance given in the Blue Book, so it is a useful, quick guide to the key technical aspects that need to be covered during the construction program. After watching this video and referring when necessary to the Blue Book, the engineer should clearly understand the key inspection issues of each of these four key stages of the classroom construction process, ensuring that the classrooms are constructed to the required quality. It is the engineer's key responsibility during the construction process that the work of the contractor is monitored in order to ensure that the classroom is being built to the correct specifications, and thus ensure that it meets DepEd's quality standards. In order to do this, the engineer must take regular inspection visits during the construction process. Ideally, inspection visits should be made at least once every 2 weeks, but this may not always be possible. The visits should be a mix of both pre-planned and surprise visits. It is, however, very important that the engineer makes every effort to visit the site at a minimum of each of 6 inspection points highlighted later in this video. For both unannounced and surprise visits, and for each of the 6 scheduled key inspection visits, the engineer must conduct the inspection with a contractor's representative. Usually, this will be the site foreman, although on some occasions, it may also be the contractor himself. Ideally, the engineer should ask the school principal to join him or her at the inspections. But if the principal cannot attend the inspections, the engineer should initially ask if the principal has any specific concerns that he or she wishes the engineer to raise with the contractor. If the principal does not attend the inspection, the engineer should try to meet the principal before leaving the site in order to update the principal on the results of the inspections. At each of the inspection visits, the engineer must check that the construction materials being used are as per the approved samples, that construction is progressing as per the drawing and specifications, that the construction progress is on target as per planned construction schedule, that the site is properly secured so that there's no access to the site for pupils, that all the contractor staff seen on site are wearing the correct safety gear, that there is no evidence of use of child labor. Where the engineer observes any infractions, he or she must discuss the issue with the contractor and must agree remedial actions. If the contractor will not agree to do the remedial works as instructed by the engineer must report the position to the school's division superintendent. Introduction of the engineer's inspection logbook. The engineer should record his or her observations in the QA logbook. together also with the details of any discussions or agreements made with the contractor in terms of issues that need to be addressed. At every site inspection visits, the engineer must record observations and details in a Quality Assurance Logbook, or QA logbook for short. The engineer's QA log is a diary of the inspections made by the engineer during the construction process. Its purpose is to maintain a factual record of observations made at each inspection. The engineer's QA logbook should not be confused with the contractor's construction logbook, which is the diary which the contractor completes each day and keeps on site. Before the start of the construction, the engineer should obtain the logbook from PFSED. The engineer should take the inspection logbook to the site at every visit, and when on the site, should input or record his or her observations on the ongoing construction activities. If during the inspection, the engineer has noted and recorded in the QA logbook any item that requires urgent attention, he or she must inform the contractor of items which are not of satisfactory standard. The engineer must also inform the physical facilities coordinator and the school division superintendent immediately by phone or by email or by face-to-face conversation. At the end of each inspections, the engineer should keep the inspection log in his or her possession to use again on the next inspection. Again, the engineer's inspection log is the official logbook where an engineer must document his or her observations during the site inspections. Stage 1. Pre-construction activities and documentation. In this stage, the key activities are site appraisal, site clearance, conducting the pre-construction meeting, verifying the actual site layout is as per the approved site development plan, conducting the pre-construction materials sampling and testing. The engineer has several key tasks to perform during the pre-construction stage. Site appraisal. Initially, the engineer must validate the site appraisal report and so must first obtain a copy of site appraisal report. The engineer must validate the report by visiting the site and assess whether the proposed site is flat or sloping and whether or not it will therefore require extra work such as cut and fill, embankment, or soil protection. In order to enhance the effect of natural ventilation and lighting, the engineer should confirm the classrooms will have a setback of at least 2 meters from the property line and will be provided with open courts. Also, the engineer must be aware that if the building is to be located at the bottom of the slope, it must have sufficient distance from the bottom of the slope provided protection from drainage. For this purpose, the minimum setback should be at least 4.5 meters. However, equally importantly, if the building is located at the top of the slope, the surfaces must be founded in firm materials sufficient to provide vertical and lateral support for the footings without detrimental settlement. The minimum setback for this situation must be at least 12 meters. In addition to checking to ensure whether an individual site would be suitable in terms of buildable space for the proposed construction, the engineer must also check other key physical aspects. These are: does the site have electricity, water, and sewage facilities? Is the site likely to be at risk from flooding? And if so, what remedial works is needed to mitigate the risk? Increasing elevation to address effect of inadequate drainage systems. Does the site have access for disabled persons from the roadside to the school entrance? Is the site accessible from the main road? Does the site have access to supply and delivery of construction materials? Site clearance. Next, the engineer must assess the condition of the site and determine if any demolition works or removal of any existing facilities are needed. For example, the removal of trees, realignment of electrical, water or drainage systems, and filling of culverts. The engineer should pay specific attention to ensuring that there will be adequate access from the road to the classroom for pupils with disability so that no obstructions such as ditches or uneven ground make it impossible for pupils to reach the classroom. Where the engineer does identify some specific problems, for example demolition of buildings on site or lacking of availability of pipe water supply, the engineer should inform the school principal immediately so that appropriate actions can be taken. Documents to be collected before construction. The engineer must ensure that he or she collects copies of all relevant documents so that can be referred to during construction to ensure that the building works follow agreed plans. The key documents the engineer must have are plans and technical specifications, the program of works, pre-construction meeting. Immediately after the notice to proceed is issued to the successful contractor, the engineer should contact the school division superintendent in order to arrange the pre-construction meeting. This meeting will also be attended by the contractor, by the school principal, and the divisional physical facilities coordinator. The key topics to be discussed and agreed at the meeting are issuance of the school principal of site possession certificate to the contractor, arrangements for the contractor to apply for the building permit, the space to be provided on-site for temporary facilities, review of the contractor's construction schedule and methodology, specifically identifying the target dates for each of the 6 key inspection dates, arrangements for sampling and testing of materials, contractor's compliance with occupational health and safety regulations, particularly to ensure that pupils cannot gain access to the site is adequately fenced, specifying the requirement for the completion of the contractor's construction logbook during the construction process, confirming the contractor's compliance to non-use of child labor. Key inspection point 1. The engineer must verify that the actual site layout is as per the approved site development plan. The contractor should set out the actual site for the building works. This should be done by physically fixing batterboard to its horizontal position to establish the actual position on the ground where the actual classrooms will be constructed. Once this work have been completed, the engineer should carry out key inspection point 1. During the inspection, the engineer must verify that the site marked out on the ground is as per site development plan, that the site is now marked out conforms with the site appraisal report, and the engineer should validate the data in the site development plan. It is also important to ensure that the site complies with any requirements due to sloping ground as identified during the physical site inspections, and the floor elevation will comply with the maximum flood level recorded in the area. Conducting the material sampling and testing. The engineer should next arrange with the contractor to carry out the pre-construction material testing. At this important testing session, the engineer will require the contractor to provide samples of all the approved components and materials which are to be used in the construction. At the end of the session, the various samples will be retained on site so that at every site visit, the engineer can quickly check that the correct materials are being used during the construction process. The engineer should invite the school principal to attend the on-site material sampling session. Generally, when the engineer observes specific materials being used during the construction process, he or she should check that the items conform to the approved specifications by reference to the sampled materials held on site. In particular, the engineer should check reinforcing steel bars, sand and gravel, cement mix, concrete hollow blocks. This process of being able to check back to the initial approved sample held on site will help the engineer in confirming his or her observations of any substandard materials being used. Stage 2. Structural construction. In this stage, the key activities are excavation of footings, erections of scaffoldings, installation of reinforcing steel bars, pouring of structural concrete, construction of masonry walls, installation of roofing framing. There are 4 key inspection points during this stage of construction process. Key inspection point 2. Once the contractor has completed the excavation for the footings and before the pouring of the concrete, the engineer should carry out key inspection point 2. The engineers must check that the excavations are completed in accordance with the approved plans, specifically in terms of dimensions and depths of the excavations. That there are no broken concrete blocks, oversized rocks, or asphaltic pavements are being used as backfills. That the excavated unsuitable materials should be removed from the site immediately. That the testing for soil poisoning has been carried out and that the results are satisfactory. That safety barriers are provided in all excavation areas. If the engineer notes during the inspection that the excavations are creating unstable ground conditions, the engineer must report this immediately to the school division superintendent and if necessary, issue a work stoppage notice or temporary suspension of works until issues have been completely addressed and resolved. Once the contractor has completed the installation of the reinforcing bars and formworks but prior to the concreting of footings and the installation of tie beams, the engineer should carry out key inspection point number 3. The engineer must check that the materials used, specifically the reinforcing bars for the footings, the tie beams, the columns, the floor beams, the roof beams, the suspended floor slabs, the ground floor slabs, and lintel beams are in accordance with specified grade as required in the plans and specifications. That the reinforcing bars have been installed in accordance with the plans and specifications. That the scaffoldings and formworks for beams and columns have been erected on site complies with the plans and specifications. Key inspection point 4. Once the contractor is ready to begin the structural concrete, but prior to the concrete pouring, the contractor must submit a pouring request to the engineer. On receipt of this request, the engineer should carry out key inspection point 4. The engineer should visit the site and check that the readiness concrete mix conforms with the approved specifications. The required minimum comprehensive strength must be confirmed as indicated in the general notes of the structural plans. That the concrete vibrator equipment is available on site. That the concrete cylinder molder is available on site. That the quality and alignment of masonry walls conforms with plans and specifications. That the safety requirements will be met. Key inspection point 5. Once the contractor has completed the concrete pouring of roof beams and the installation of roof framings, roof sheets, and roof ceilings, the engineer should carry out key inspection point 5. The engineers must check that the materials used on roof trusses, roof sheets, and ceiling conforms with the plans and specifications. That the anchorage of roof trusses have been properly made in accordance with the approved plans. Checking that anchorages have been properly made is a very critical point in the process. Examination of many classrooms damaged by Typhoon Yolanda back in November 2013 showed that much of the damage was caused as a direct result of failure to anchor the roof trusses. This point is clearly demonstrated in the photos. These show 2 adjacent buildings, one of which was severely damaged. The roof cover and ceiling were completely blown off, whilst the other building of similar design was relatively undamaged. Inspection of the damaged classroom showed that the roof trusses had not been properly anchored to the beams and that the walls did not have adequate steel reinforcements. Another similar example is shown in these photographs. Again, in this case of 2 adjacent classrooms, one was relatively undamaged, whilst the other was severely damaged with again the roof completely destroyed. The damage was due to failure to achieve proper anchorage of the roof to the roof beams, as the result of entire roof was lifted off the classroom and blown some 100 meters or so away from the building. Both the examples highlight the damage was caused by failure to construct the classroom to proper building standards rather than because of faults in the design. This poor quality workmanship should have been detected at the routine quality assurance inspections during the construction process. Stage 3. Internal and external fittings. In this stage, the key activities are installation of doors and windows, installation of electrical and plumbing systems, painting and tiling works. There is one key inspection point during this stage of the construction process. Key inspection point 6. This inspection should take place once the contractor has completed the internal fittings and finishes, covering installation of doors and windows, installation of electrical and plumbing systems, and painting and tiling works. The engineer should carry out key inspection point 6. The engineer must check that all the materials used conforms with plans and specifications. This is particularly important in respect of door fixtures and the blackboard and the security grills. That the finished masonry wall surfaces and carpentry works are done with the highest quality of workmanship. That the installed electrical fixtures and toilets and water supply have been installed as per plan and are all functioning correctly. Stage 4. Finalization and handover. In this stage, the key activities are punch listing, issuance of certificate of completion, defects liability period. Punch listing. Punch listing is the final quality assurance check to ensure that the construction has been completed in accordance with the plans and specifications. This requires completion of the punch list, which records the inspection team's findings of defects, deficiencies, or any remaining works. It is the engineer's responsibility to record the inspection team's findings in the punch list so that outstanding works can be agreed and monitored, and any defects or omissions must be rectified before the contractor can hand over the building to DepEd. When the contractor advises the engineer that all tasks of the punch list have been completed, the engineer must check to ensure that the works have been carried out to the correct standards. When the engineer is satisfied that all works have been completed, the engineer can advise the school's division superintendent and the principal accordingly so that the certificate of completion can be issued, and therefore the contractor can now hand over the classrooms to DepEd. Finally, it should not be forgotten that the contractor remains liable to remedy any defects in the construction works which may arise during the 12 months after the date of issuance of certificate of completion. The certificate of final acceptance is issued at the end of 12 months period, assuming that everything is satisfactory. Let us just recap the key points that have been covered earlier. The engineer's motto should be, quality assurance monitoring is the key to ensuring quality construction. And in order to ensure the classrooms are constructed according to the specifications and are built to the correct quality standards, the engineer must aim to visit the site at least once every 2 weeks during the construction process. These inspection visits should be a mix of scheduled and surprise visits to the site. It may not always be possible to make a visit every 2 weeks, but as an absolute minimum, the engineer must visit the site when construction reaches each of the following points in order to carry out the 6 key inspections. Inspection Point 1. On completion of site layout before any excavation work starts. Key Inspection Point 2. On completion of the excavations before the installation of reinforcing bars and formworks. Key Inspection Point 3. For a single-story construction, this key inspection point is on completion of the installation of reinforcing bars and formworks prior to the completing of footings and installation of tie beams. For a 2-story construction, key inspection point 3 should take place on completion of the installation of reinforcing bars and formwork beams, suspended slab, and stairs. Key inspection point 4. Immediately prior to the pouring of structural concrete and construction of masonry walls. Key inspection point 5. On completion of concrete pouring of roof beams and the installation of the roof framings, roof sheets, and roof ceilings. Key inspection point 6. On completion of internal fittings and finishes, doors, windows, plumbing, and electrical works, including painting. For both unannounced and surprise visits, and for each of the 6 scheduled key inspections, the engineer should carry out the inspection jointly with the contractor. Where possible, the school principals should also attend. Check that construction materials being used are as per the approved samples. Check that construction is progressing as per the drawings and specifications. Check the progress of the work against the construction schedule. Any infractions noted by the engineer must be discussed with the contractor and remedial action should be agreed. If not, the school's division superintendent must be notified. At the end of each site visit, the engineer should enter the details in the QA logbook. If the engineer is satisfied that the quality assurance monitoring has been implemented as set out in this video, he or she can be confident that the finished classrooms have been constructed to the highest quality and be happy that the high standard of the finished classrooms will be enjoyed by teachers and pupils for many years to come.